Hello everyone, this is Mohan Karthik. Today I am going to tell about a project which is stock market prediction. It is based on XGB Regression model where we have used a machine learning model to predict the next day's stock price, and it will tell whether we have to buy the stock or we have to sell the stock. Now let us go into our project. Now before going to our project, we have to install the packages and libraries required by our project. First one is Yahoo Finance. It contains the historical data of stock market, pandas for data manipulation, and scikit-learn for machine learning models and evaluation matrices, matplotlib for data visualization, seaborn also used for data visualization. Now let us import yfinance, pandas, and train underscore test underscore split. It is a function which splits the dataset into training dataset and testing dataset. Now we have to import our XGB regressor. Now let us import the evaluation matrices, mean squared error and R square error. Both are used to check the performance of our XGB regressor. Now let us import NumPy for numerical operations, and we have to import matplotlib for plotting the graph. Now let us go to the first step. Here, first step we have declared a ticker. Ticker is a label given to stocks. Here we have considered Reliance.ns. NS means National Stock Exchange. Now here we have defined start date as January 1st, 2020 and end date as today. Here we have to download the stock information from start date January 1st, 2022 today, and it will be stored in data. Now let us print the first 10 rows in the data.head parenthesis 10 means it will print the first 10 rows. Here you can see that on January 1st, the closing price is 687 and highest price recorded on that day is 695 and lowest price is 686 and opening price is 691 and volume means on that day the stocks amount is this much. Now let us go to the second step. Here we have used data pre-processing means the rows which having missing values will be deleted. Now let us go to creating features. Here we have created some features high minus low. High minus low is a feature which subtracts highest price minus lowest price. It will tell how much fluctuation in the stock prices. Close minus open, it will tell whether the stock has increased or decreased. Means on that particular day, stock has went up or down. Now again, we have used 5 days mean average and 10 days mean average, and we have done data pre-processing. Now let us define target. Target we have defined as next day's closing price, and we have done data pre-processing. Now let us define features. Here we have defined features as open, high, low, closing price, volume, high, low, close open, 5 days moving average and 10 days moving average. And we have defined our target as next day's closing price. Now let us split the data set. We have used train underscore test underscore split to, to divide the data set into two parts. One is testing data set and one is training data set. Here we have passed test size as 0.2. That means 20% testing data set and training data set as 80%. And we have passed shuffle equal to false. That means here we have considering stock market data as it is a time sequence data. Chronological ordering is mandatory. To that, we have passed shuffle equal to false. Let us initialize our XGB regressor and let us train our model using model.fit. And now let us our model make predictions. Now let us evaluate our model using root mean square and R square. Here we have used root mean square error and R square error to check the performance. Now let us print both of them, and now we have to, for better visualization, we have to, here we have created a table which contains actual prices and predicted prices. Now let us print those last 10 rows of that table, and now let us plot a graph between actual prices and predicted prices of last 20 days. Okay, let us, and that graph contains x-axis as index and y-axis as price. X-axis as index means the each day, and y-axis prices means actual prices and predicted prices. Now let us see the root mean squared error calculated is 30.94 and R square score as 0.9 means our model is somewhat good. Now let us see the actual versus predicted price differences. Here you can see the price differences is 20 to 30 and our model is somewhat good. Now let us plot the graph. Here you can see the blue line indicates actual prices and the red line indicates predicted prices. And on x-axis you can see the days and y-axis prices. Now let's see the last step. Here we have considered most recent data and it will be passed to our machine learning model and it will predict the next day's closing price. And these are the prices of most recent data. It is the opening price of recent data stored in our Yahoo Finance stock market information. And here we have done price difference between next day's closing price and opening price, today's opening price. And we have done if the price difference is greater than zero, that means next day's closing price is greater than the opening price, then we have to buy the stock. And if it is not like that, we have to sell the stock. You can see these are the outputs, means the next day's closing price is 1235 and today's opening price is 1234. That means next day's closing price is more, then we have to buy that particular stock. Thank you. Let us see what is XGBoost. XGBoost is a powerful and efficient implementation of gradient boosting algorithm. It is widely used in machine learning tasks due to its high performance and scalability. Now, let us see what is XGBoost regression. XGBoost regression is a type of supervised learning algorithm used for predicting continuous values. It builds an ensemble of decision trees where each tree corrects the errors of previous trees. Now let us see the key features of XGBoost regression. First one is regularization. Includes L1 and L2 regularization to reduce overfitting. Parallel processing. Fast training using multi-cores. Handling missing data. It handles the missing data during training. Tree pruning. Uses a depth first approach for optimal tree construction. Let us see how it works. Starts with an initial prediction using the mean of the target, builds decision tree iteratively. At each step, it adds a new tree to minimize the residual error using gradient descendant. The final prediction is a sum of predictions of all the trees. Let us see some applications of XGBoost. First one is house prediction, stock market prediction, energy consumption prediction. Any regression task can be done using XGBoost with an high accuracy.